Okay, here we are, back again. We're going to work on determinants and later on Kramer's rule, but in this video it'll be on determinants. And this will give us another approach to solving a system of linear equations. Now, so far we've done it by graphing back in pre-calc 1. Um, and in this course, we've worked on algebraic systems. We've worked on 2x2s and 3x3s where you add and subtract. And then we did a matrix approach where we learned about row operations, where we could interchange rows. We could multiply a row by a constant, or we could add a constant multiple row to another row, all right? And we did that using matrices. We're going to soon begin something called Kramer's rule, which is a kind of a very nice method which is used in computer systems a lot because it's mindless, okay? But in order to do that, we need to work on something called a determinant, okay? A determined ant. All right, determinants. The problem set that will go along with this is going to be exceptionally easy. So this is one that everybody wants to do. It's a good way to get back in the game. It's going to work out really nicely. Okay, so let's start out with the definition. A determinant is a square array of numbers enclosed by two vertical lines. So this is a determinant. It's called a 2x2. And by the way, when they say 2x2, the first number is the row, the second number is the column. So 2 rows, 2 columns. Now I know these are square arrays, so it really doesn't matter. But if you're talking about matrices later on, it's always the row number that comes before the column number. How do you remember that? Well, back when I was a kid, they had something called Royal Crown Cola, RC, Royal Crown Cola, in competition with Pepsi and Coke. I don't know if it's even still in the market. So R before C, rows before columns. Okay, and the way we do this, the value of a determinant, if you take a look at this, it's AD minus BC. Now, how do you remember that? It's A times D, the product of the terms in the main diagonal, minus the product of the terms in the minor diagonal. So it's AD minus BC. Now, for a 3x3 determinant, it's quite a bit more complicated. Okay, so the value of this determinant here is this crazy expression, and I'm going to give you a much better way of doing it. Well, let's just do a quick review. Yeah, AD minus BC would be how we evaluated 2x2. To do a 3x3, there are several methods. Okay, the first method is called the extra columns method. And what we do is we simply take the first column and the second column and we rewrite them. Okay, and then we take the three products of the main diagonal types. This, so A1 times B2 times C3, main diagonal product, another diagonal product, another diagonal product, and we add them. Those are pluses, and from that we subtract the diagonal products going in the other direction. So A3, B2, C1, so forth and so on. I understand the pattern. I'm not, worried about this. Now, the tricky thing is that method 1, this extra columns method, only works for 3x3s. Okay, so we're going to learn something called minors of an element later, but before that I want to go and do some examples. Let's do some examples, and this is on Blackboard. Okay, so you can print this out, do it to your heart's content. It's very easy. All right, so in examples 1, 2, 3, we have 2x2 determinants. And clearly, let's follow the method. 5 times 2 minus 4 times 3. So 5 times 2 minus 4 times 3 is 10 minus 12 or negative 2. So the value of this determinant is negative 2. All right, we do the same thing here. 8 times 5, take away negative 6 times negative 3 times negative 2. So 40 minus 6 is 34, my age, coincidentally. Okay, you can even do a determinant equation where you have 3x times 4, take away negative 2 times x. So you get 12x, minus a minus is a plus, plus 2x. So you get 14x is negative 28, x is negative 2. Okay, so let's do this extra columns method, which is what, I don't know if it really has that name, but that's what most people refer to it as. So this only works for 3 by 3. So here we go. The extra column method says you multiply, in this case, and you can see that the determinant is negative 1, 0, 2, 3, 0, 1, and 0, 1, 3. Okay, so if you multiply this, if you have a 0 in any diagonal, it's going to give you a 0 product, right? So this is going to be 0, this is going to be 0, this is going to be 6. So the plus terms going from upper to lower, from upper left to lower right, would give you 0 plus 6. And now we take away what we get when we work from the upper right to the lower left. So this has a 0 in it, so that's a 0. This is negative 1 times 1 times 1, which is negative 1. And this is 0 times 3 times 3, so that's going to give us a 0. So we get, take away now, 0 plus negative 1 minus 1. So you get 6 minus negative 1 was 7. Okay, so you may want to pause the video for a couple seconds and try this one. So we'll wait a couple seconds, and here we go. Okay, 5 times 1 times negative 1 is negative 5. 0 times anything is 0. 0 times anything is 0. So the upper left to the lower rights, the positives give us negative 5 plus 0 plus 0, which is negative 5. And then we take away, going the other direction, from the upper right to the lower left, negative 4 times 1 times negative 4 is 4. And then we do 5 times 3 times 2 is 30. And then we do, well, you got a 0 here, so it's a 0. So you have negative 5 minus 34 is negative 39. Okay, so that's how we do the 3 by 3. Now the next topic is expansion by minors. This is important. All right, so let's go back to the theory on that. And let's define what a minor of an element is. The minor for an element in 3 by 3 determinant is the determinant, so it's a smaller determinant consisting of the elements remaining when the row and column of the element are deleted. So in other words, here is the original 3 by 3. And we're going to do this for numerical examples, so bear with us. Let's suppose we're talking about expanding along row 1. Okay, this is row 1. We're going to look at the minor for element A1. So here's A1. Now the minor means we don't look at everything in that row and we don't look at everything in that column. So what we're left with is this 2 by 2 right here. And I wrote that down. So the minor for element A1 is this smaller 2 by 2 determinant right there. Okay, so let me repeat again how we do that. If we want to find the minor for row 1, we go element by element. First we look at element A1, and we're going to look at for the minor for element A1. We eliminate in our minds all the elements that are in the column, in the row of A1, and all the elements that are in the column of A1, and we're left with this 2 by 2. Okay, so that's called a minor for element A1. Now, for element B1, we eliminate everything in the row and column that B1 lies in, and you're left with A2, A3, C2, C3. So this would be the minor for B1. So take a few moments, and we're continuing along this row. So see if you can find what the minor would look like for element C1. So take a moment, you can pause the video, okay, come back to it. Okay, welcome back. So if we're looking for the minor of element C1 in our mind, we eliminate the elements in a row and column where C1 lives. And we're left with this 2 by 2 determinant here. And that's exactly what we get. So these are the three minors for the elements in row 1. Okay, now here's an alternate way of evaluating a 3 by 3. And this method is called expansion by minors. Now, it's not the extra row method. The extra row method, or the extra column method, actually only works for 3 by 3s. The expansion by minors method works for all determinants. So it's a more general and a more valuable way to go. We're going to work with this Kramer's rule in a later video. Let's see if we can nail down the mechanics of this now. Okay, so this is called expansion by minors, and this works for all higher degree order determinants. So this is very good. Okay, so step 1 is we choose any row or column to expand upon. Step 2 is we write the product of each element of the row or column with its minor, and we connect the above products with the proper sign from the sign array below. Now, here we go. Let's say we're working with a 3 by 3. Here's what we do. I mean, this is so simple. The upper left-hand corner is a plus, and then as we go in any direction, we just alternate the signs. Simple. So we always begin with a plus in the upper left, and we alternate signs. Okay? So, notice, let's see what this says. Now, this is on Blackboard. You can print it out. The sign is positive when the sum of the row and column positions is even. Now, I mean, this is a little theoretical because in math sometimes we want formulas for things, but basically, you can do this by just starting upper left-hand corner is positive and then alternate signs, okay? But here's what the real rule in mathematics is. You look at, let's suppose we look at a particular element. This element is in row 2, column 3. Since 2 plus 3 is odd, it has a negative sign. This element is in row 3, column 3. So 3 plus 3 is 6, that's even, so this element would have this minor was going to have a plus sign. Now, this is the way it's done in theory, and there are reasons for this because then you can write formulas for it and things of that type. But for us, we're basically, as I said, we're going to start upper left-hand corner is positive and then alternate the signs. That's even easier. Okay? Okay, we're not going to get into Kramer's rule now. We're going to wait for next time. But what we're going to do is we're going to go and look at some examples. Okay, so these are handwritten. Okay, and these are on Blackboard. Okay, so method 2 is expansion by minors method. And, okay, so let's see if we can do this now. Example number 6. List the minors for row 1. Well, here's row 1. Duh, right? Row 1, row 2, row 3. This is row 1. So, to get the minor for this element of row 1, we block it out in our mind, and we're left with 6, 4, 7, -1. All right? That's a determinant. Now, moving along row 1, because that's what we're doing here, we block out the elements in the column which 3 lives and the row, and you're left with -2, 3, 4, -1. Ta-da, that's where that comes from. This is not, magic stuff, really. Okay, so, so to get the minor for the 7, you block out the row that it lives in and the column it lives in. You're left with, I don't know, -2, 6 going this way, 3, 7. Okay, there you go. Now, here's how we expand by minors along row 1 is we take the minors, the minor determinants, which we computed in these places, okay, and we affix the SIGNs. So plus minus plus, right? So plus minus plus, and we also multiply by the actual element. So this will be the minor times plus 1. This would be the minor times negative 3. This would be the minor times plus 7, right? Because it's plus minus plus. Okay, so this is how we're going to compute the value of that 3 by 3 expansion by minor. So let's work this out. This is easy. It's easy to do a 2 by 2. Right, 6 times negative 1 minus 4 times 7. So negative 6 minus 28, we're going to see here that's negative 34. We multiplied it by 1. To do this one, it's 2 minus 12 is negative 10, but we're multiplying by negative 3. So negative 3 times negative 10 is positive 30. And over here, you get negative 14, take away 18, that will be negative 32. We're multiplying it by 7. So you get negative 34, 30 minus 224. So the value of this 3 by 3 is negative 228. Now, let me see if this is the same one that we did now. You see, what I should have really done is I should have said, okay, now as an exercise, go ahead and do the extra columns method and write 1, negative 2, 3 here, 3, 6, 7, and do the extra columns method and verify that you get the same result. And if you spend a few moments, you educate yourself, you convince yourself that what I'm saying is true, you'll see that it works out, okay? So this is a nicer method because this method works for all sizes of determinants, okay? So now you're probably wondering, well, gee, we expanded in minors for row 1. What if we expanded in minors for someplace else? Let's say column 2. So let's do that. So what I want you to do is I want you to go back to the original, and I want you to expand using the minors for column 2, right? This is column 1. Columns are up and down like the pillars in front of a building. This is column 2. This is column 3. So I'll start you off. If I'm starting here, I'm going to be working down, starting here, right? I imagine blotting out those, and I get the minor for this element in the first column is negative 2, 4, 3, negative 1, and you can see that's what I wrote down. Okay, so I want you to take a few moments and expand and get the other minors for column 2. So we're going to pause the video, hopefully, wait a few moments. Okay, I don't know how long you paused it for, maybe you didn't, but that's okay. So now what we're going to do is going to continue working. We expanded about the first element in column 2, which is the 3, and now we're going to expand about the 6, and you're going to get 173, negative 1, 173, negative 1, and now we're going to expand about the 7, blocking those out, so 17, negative 2, 4. And the other deal is that we now multiply by 3 by 6 by 7, 3 by 6 by 7, but we also have to take into account the SIGNs, the signs, okay? So don't forget the way we do this, upper left-hand corner is a 1, they alternate. So this would be a negative and an alternating positive, negative. Okay, so you can see where I got the SIGNs from. So this I work out, and here we go. This times this is 2, minus 12 is negative 10. This times this is negative 1, minus 21 is negative 22. And 4 minus now, negative 14 is positive 18. And then I multiply by the values with their SIGNs, and if you work this out, you get negative 228. Same thing. So the moral of the story is, not only is this an easier method, it works for all size determinants, but it doesn't matter the column or the row that you pick to expand by minors. So what that means, if you have a column or row that has one or more zeros in it, you should pick that column or row to expand by because that's going to save you work. Okay, so let's look at some other examples. Okay, and this is on Blackboard. Okay, so we'll just try these. All right, so question 7, evaluate. That's not hard. Boom, boom, right? 8 rather. 2 times 4 is 8 minus 3. 8 minus 3 is 5. Duh, easy. Solve for x. Okay, so this times this is negative 3x minus 4x is 21. Negative 6, 21x is negative 3. Easy. Number 9, expand by minors. And it says here, I will expand along row 2. I chose to do that. We haven't used row 2 yet because one of them is a 0. So here we go. This starts out with a plus. All signs alternate. So this will be a minus, plus, minus. So minus, plus, minus. You can see the way I work this out. And then the minor for this element would be negative 1, 0, 1, 2. And the minor for this element would be 2, 0, 0, 2. And the minor for this element would be 2, negative 1, 0, 1. And you can see the way that works. Works out really easily. And just as a reminder, this is your sign array. Okay? Number 10 and 11, I'll leave for you. Like I say, it's all worked out. So go for it. Give it a try. And next time we will come back. In fact, I think I'll give a separate problem set on just determinants because it's easy. It's a good boost to your grade and, a little bit of self-confidence. I know the last one was probably a little tougher with the rotation of axes and then the parametric. So this will be a little bit easier for you. Okay, so again, next time we will do Kramer's rule, and the skills we just learned are going to come in very handy, and Kramer's rule is going to give us a really cool way of solving systems of equations. All right, so with that, I bid you adieu, and here we go. Goodbye.